All right. Today we're going to work our way backwards, is that we will be using zeros given to us to find the polynomial that it came from, and understanding how to work forwards and backwards through all this information. It's very similar to the idea of, okay, so why would we move this direction? All those different situations where we need to factor compared to when we need to FOIL, and sometimes you need each technique. So now they're going to tell us what the zeros are, and we're going to go find the polynomials. Reminder that we have all sorts of different questions and what those different types of answers are looking like. So vocab words, half the time is understanding the question and what it is asking you for. So remember, when we are looking for zeros, our answer will be just plain numbers, right? This could also be the same question as find the roots or solve. Those would all be the same questions as find the zeros. An example of what our answers could look like would be something like 1/2, -3, and plus or minus 4i. Okay, those would all be examples of zeros. Solutions, roots. If the question is to find the factors, factors are always going to be in parentheses. So that would be like x plus 2, x minus 1 squared. Those would be examples of factors of a polynomial. And a polynomial, if the question is asking us to find the polynomial, I will tell you that at some point you will need to FOIL your work, okay? And we always will go this direction, knowing what the factors are going to our polynomial. You'll set up factors and FOIL to get to the polynomial. But if the question at the top says, what is the polynomial, at some point you're gonna have to FOIL to get there. So like this right here is my factors. I have not FOILed yet. That would not be a polynomial. If I use that as my example right here, to get to the polynomial, I would FOIL, do one set at a time. So like x minus 1 times x minus 1 would be x squared minus 2x plus 1. FOIL again. We would get what? X cubed minus 2x squared plus x plus 2x squared minus 4x plus 2. And so your polynomial, usually indicated by like an f of x, g of x, h of x, something. Combine all those like terms. Here's your example of a polynomial. Would be x cubed. My x squareds cancel there. Minus 3x plus 2. That's a polynomial. All multiplied out. They're all related to each other. We just need to make sure that we understand how to answer the particular question that is being asked of us. Did they ask us for factors? Did they ask us for zeros? Did they ask us for a polynomial? Today we're focusing on the polynomial part of it. Again, to get to a polynomial, we'll have to go through factors to get here, okay? All right, so doing that, maybe. This is what our questions are gonna look like for part of today. It says, write a polynomial. Given the zeros, write a polynomial, and it does say of least degree. I will tell you that there are options through multiplicity that could have the same zeros listed, but I don't want to do that much work, so we're going to pick the smallest degree that would have these zeros. So here's just a reminder. First of all, when we are moving, we go from zeros to factors. So the first thing you're going to write is your factors. And remember to go from zeros to factors. It's always going to be opposite signs, because it is in a factor x minus your 0. So the -3 is an easy one to do. Its factor will just look like x minus -3 or opposite sign x plus 3. Okay. Let's talk about the other two. They are on here for a reason because I want to talk about, okay, if we are given a 0 that is a fraction, or if we're given a 0 that's a 0, how do those look? Because they're a little unique. So let's talk about just a fraction off to the side here. Work our way backwards. That means I had some factor here. I took what was inside, I set it equal to 0, and I solved. And when I solved, I got to the fact that x equals 2/3. So let's talk about unsolving that. Unsolving that, the last thing I would have done was divided both sides by 3. So I would undo that. I would have a 3x here, right, equals 2. And then to get it back to 0, I'd bring that 2 back over, which means my factor would have been 3x minus 2. So let's look at the fraction and where those things end up in our factor. Okay, so the fact that they told us that our 0 was 2/3, notice opposite sign. This goes to in front of x. So your denominator is going to go in front of x. Opposite sign, whatever the numerator was. So let's practice one more here. What if my 0 was, how about -3/4? Write the factor. If your 0 is -3/4, what would the factor look like? Okay, denominator goes in front of x, numerator goes after x, and we pick the opposite sign of what's there. So it'll be a 4x plus 3 would have been our factor. Are we good on moving from a fraction 0 to what the factor looks like? Okay, so let's put that one up here. This 2/3 would end up being 3x minus 2. Okay, and then what if I have a 0 in my list of zeros? What does that look like in my factors? X. It's x. Okay, so there's our last unique one here. If I have a 0, and I'm always going to put that out front, is just a plain old x. Okay, so now let's talk some algebra. Remember, this is your factors, right? But the question is find the polynomial, which when the question is find the polynomial, that means I need to FOIL to get there. And I have not FOILed yet. So we are not at a polynomial yet. When you have multiple parts, do one part at a time. So we have multiples. I will always save the distributing to last. So if you have just a plain number out here, or a plain x, I will always save that for last. So I'm going to FOIL here. Just bring that guy down. When I FOIL here, what do we get? 3x squared minus 2x plus 9x minus 6. And then distribute 3x cubed plus 7x squared minus 6x. That is a polynomial. Questions? All right. That's what we're doing today mostly. We're going to see a little variations and one little twist on this as we get a little bit more information about our polynomial. The things that we have yet to see is multiplicities, and we've also yet to see imaginary zeros and how we work those into our factors and eventually then our polynomial. So let's look at one that has an example with a multiplicity. This time, same directions, write a polynomial of least degree that follows this information. We've got a 0 of 1 with a multiplicity of 2 and a 0 of -4. So again, step number 1, go from the zeros to the factors, but we're not done because if it says polynomial, we will have at some point had to have FOILed. Okay, so if we have a 0 of 1, remember opposite sign. So inside my parentheses, it should say x minus 1. Good. Okay, before we move on, it does specify that it has a multiplicity of 2. What does that mean? Exponent on the outside, right? So let's go ahead and put that on there. That's why I will have a squared here. Anytime we have a multiplicity, we're going to put that on the outside of our parentheses. And then our 0 of -4, again, opposite sign, so x plus 4. Any questions on that? Okay. So then we go ahead and I would write this twice in FOIL because of the multiplicity, right? Multiplicity means write it out however many times it's there. So squared, I'd write it twice. It does not matter the order that you FOIL. We should end up at the same answer at the end. And if you are not, you're making a mistake somewhere in there. If your table partner did the first 2 first and you did the second 2 first, you would still get the same answer at the end. Pick 2 and FOIL. Remember that when I'm taking 3 things times 2 things, again, order does not matter that you have those sitting, but you do need to be careful. Take each term and distribute it all the way through. So I'm going to take this x squared and distribute all the way through, which would give me x cubed plus 4x squared. And then I take my next term and I distribute it all the way through, which would give me a negative 2x squared minus 8x. And then I take my last term and I distribute it all the way through, plus x plus 4. And then to finish up, we just combine any like terms that we would have. I only have one x cubed, so that's not changing. I have an x squared here and an x squared here. 4x squared minus 2x squared would be 2x squared. I have a plain x and a plain x, so negative 8x plus 1x would be a negative 7x. And just one constant, so that's not going to change. There's your polynomial. Okay, we do need to make a side note on this one. So any questions before I make my side note? So we just learned how to do a multiplicity. The unique one is what if our 0 was 0 with a multiplicity of 2. First of all, we know that a 0 of 0, when we go to do our factors, looks like a what? A plain x, right? So it doesn't have a parentheses, but with a multiplicity of 2, it would be directly on the x. So there, let's try that again. There's your multiplicity of 2 on a 0 of 0, okay? So there's your, a little unique to 0 only. Questions? All right. Now we're going to add a little bit more to our information. So in this one, we're going to see how to deal with an imaginary 0. We're also going to have to deal with some additional information to have an even more specific polynomial. So look at all these directions. Find a 4th degree polynomial, which means at the end of this problem, our biggest exponent should be a 4. Okay. Find a 4th degree polynomial function with real coefficients that has -2, 2, and I as the zeros. Okay, so I'm going to write that out specifically here. Take it out of our information here. They're telling me that I have zeros of -2, of +2, and of I. And then they give me some information at the end that says that, okay, well, when I plug 3 into our function, I get an answer of -150. Okay, so we'll get to that at the very end. We're going to hang on to that. But we need to go talk about our list of zeros. I know that this is going to be a 4th degree polynomial, which means I have 4 zeros, but they only told me 3 of them. Yesterday, we learned something about polynomials dealing with imaginary numbers. Does anyone remember what that was? Yes, imaginaries are always plus or minus. And I said, again, that we weren't going to necessarily see it yesterday, but this is huge, is they will only ever give you one of those two imaginaries. You have to remember that if they give you an imaginary, that it automatically comes with its imaginary friend, the plus or minus, right? So whatever one they gave you, it would also include the conjugate of that. So the conjugate of I would be negative I. You have to add that to the list. Questions? Always add to your list the conjugate of the imaginary they gave you. Typically, that's just going to be the opposite sign. We had I added negative I to the list. Okay, so now again, I go from my zeros to my factors. Opposite signs here, so x plus 2, x minus 2. This is the first time we're seeing putting I in there. You don't have to overthink it, but I'm going to help you speed up our process here in a few minutes. X minus I and x plus I. Okay. Now this one requires us to FOIL and FOIL and FOIL because there's 4 different parentheses up there. So we do have to do a little bit of work. I can do 2 of them at one time. So I can FOIL these first 2 and I can FOIL the last 2 kind of all in the same step. So if I do the x plus 2, x minus 2, first of all, that's a difference of squares. I would get x squared minus 2x plus 2x, right? Or x squared minus 4. Very similarly, with your imaginaries, it is going to end up being a difference of 2 squares. Always, because you have your conjugate here. So it will always end up being x squared minus ix plus ix. And then we need to remember our work with complex numbers here. Negative I times I would be negative I squared, but negative I squared, I squared is negative 1, right? Okay, and negative 1 would be positive 1. Okay, we're going to go back and explore that part in just a second. I'm going to finish out this problem before we do. I would have to FOIL one more time because I still have parentheses in there. So FOIL one more time, which would give us, let's see, x squared, oops, not x squared, x to the 4th plus x squared minus 4x squared minus 4, or x to the 4th minus 3x squared minus 4. Okay, now our extra information. Okay, and so here's how when we are given that extra information, how we will attack this problem. Right now I'm looking at a polynomial, and what we would do is say, okay, it is some multiple of this polynomial, and we just put a little multiple out front. Now this should look similar to your warm-up from yesterday where you saw that little a sub n. And so at this point we use the given information and say, okay, for each of our x's, f of x, we're going to plug in a 3, and I should get an answer of negative 50 when we are done with this. And we got to figure out what a sub n has to be in order for that to happen. So I'm going to plug in a negative 3 here, plug in a negative 3 here, and say that this equals, there we go, negative 150. Now we've actually already done this one. I believe this was exactly our warm-up yesterday, if I'm remembering the numbers correctly. Okay, so that's 81 minus 27 minus 4, which ends up being 50, or a sub n is negative 3. Okay, finalize the problem. We're going to come back here and sub in negative 3 for that a sub n and distribute it through my problem to get the actual polynomial. Now, I absolutely think you can skip some of these steps. I'm showing all of my work right now. Distribute that through. And our polynomial would, specific polynomial to this information would be negative 3x to the fourth plus 9x squared plus 12. All right, what questions do we have? Yeah. No. Why did I do that? Why did I do that? Why did nobody stop me? No, you do not change the sign. Luckily, they were all squared and they came out positive. No, you don't change the sign, guys. I don't know why I did that. Should have been a 3. X equals 3, we plug in 3. Luckily, it's not going to change our answer because it was squared and raised to the fourth, would both come out positive. Yes. 3. Yes. So I just went through here. There was an X here and there was an X here, and I put in whatever X number they told me. I was supposed to put in whatever X number they told me. So I was right here. I just added some variable. Your book uses a sub n. You can call it z for all I care. But we plug in for any X, the number they gave us. So I plugged in a 3 here, plug in a 3 here, figure out what number this is. So then it's that number times our a sub n. So then I divide by the 50 over here to figure out what that specific a sub n was supposed to be. So then I went back to here and I replaced this with the number I got and I distributed it through the polynomial. So I took negative 3 times each of the numbers in front to get our actual specific polynomial. It's not specific to this information. So if that was different, then the answer would be different. Correct. But we would still get the same first polynomial. Correct. Because they would all have the same zeros. It's just kind of like how high or low it's getting vertically stretched, if we remember our transformations. So this one ended up with like an ROX and a vertical stretch here, which gives us different Y values at that particular X. And so this one is very specific to this given information. This is just any general polynomial that is some multiple of that. Okay. Other questions? Oh, great questions. Other questions? Okay. I get that that was a lot of process. You will be able to speed that up a little bit here as we get going. So this one is a little bit smaller because it's only a 3rd degree polynomial. So again, we expect 3 zeros. We expect our exponent at the end to be a 3, right? All of those things that tie together. And it says that we've got real coefficients or zeros of negative 3 and I, which means I'm automatically going to add what to my list? Negative I, right? Write those into my factors. Opposite sign, so I'd start out with x plus 3, and then let's look at x minus I and x plus I. Okay, here is my practical piece of advice for you. When you are dealing with imaginary zeros, it always will have its conjugate, okay? Yes, you can pick your order of multiplying, but I would always multiply that conjugate imaginaries first. It will always clean up to not have an I left over. And it is way, 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 way easier to do those first, okay? Now, sidebar here, when we were learning how to divide these things here, we talked about a shortcut that said, okay, if the bottom of my polynomial here was something like 3 plus I, and I multiplied top and bottom by its conjugate, which would be 3 minus I. Do you remember doing this? Okay. We talked about a shortcut here that if it was the conjugate, which is what we are going to be looking at, that yes, we could FOIL it, but we could also speed up our process because it was always the first thing squared. Yeah. Plus, always plus. The second thing squared, well, our second thing is just 1. Squared is 1. The number in front of it is 1. So 3 squared and 1 squared. So it's always, and I think I wrote this out here, but first squared plus second squared. Okay, can I do that with my factors when it's an x and an I? Absolutely. When you are dealing with factors that involve imaginaries, it will always be your first term squared, which is x. It will always be plus, and your second number squared. So again, our second number happens to be 1, squared is 1. That's how we get imaginaries, a squared plus. So again, if I were to give us a second example here, what if my factors were x plus 3i and x minus 3i? Well, when I FOIL that, I can make this faster. First thing squared, always plus, second number squared. Well, 3 squared is 9. So we can speed up your process and not have to FOIL if you understand where those imaginaries come from. Questions on that? Okay, let's go back and finish our problem. Bring that guy down. Keep working here. So now I'm going to FOIL and get x cubed plus x plus 3x squared plus 1. And remember, that's your generic one. So our f of x is going to be some multiple of that. And based on the given information, and I'm going to go ahead and write that in standard form, not to throw anyone off here. Based on our specific information, then that f of 1 is going to equal 8. We're going to put that in here, that 8 here, and the 1 in for all my x's, and figure out what multiple of that we are looking at. So what a sub n we would use. So we'd say 8 equals a sub n, fill in the actual number that's there, which is 1. All right, let's figure out what this is. 1 plus 3 is 4, plus 1 is 5, plus 1 is 6. Okay. And it looks like a sub n is going to be, if I simplify that fraction, 4/3. Yes. Plus 3, isn't it? Guys, what is going on? It's Friday. It's 2020 and COVID. Can we just lump all that together? So 1 plus 3 is 4, 5, 6, 7, 8. Oh, it's a nicer a sub n, isn't it? So if I multiply by 1, is it going to change anything? No. So it is really a 1. I'll go ahead and show that. Distribute the 1 through, does not change anything. So our specific polynomial with that matching information, if I can get all things written correctly. Questions? All right. See if I can get through a problem without me making a huge mistake up there. I think this is our last one today. Just wanted to show you the different way that it can be asked. This is specifically taken directly out of your book and the formatting that it was given. If it says n equals 3, remember that n equals 3 means degree of 3. So again, 3 zeros, biggest exponent is a 3 when we're done. Next to that is the zeros. 4 and 2i are zeros. If they say 4 and 2i are zeros, what's also a 0? Negative 2i, right? And then that specific information given there to help us figure out our multiple at the end. Okay. All right, let's practice that shortcut that I just talked about. So setting up my factors from the zeros, remember opposite signs here. So x minus 4 and then x minus 2i and x plus 2i. Always start with your imaginaries. Use your shortcut. Try out the shortcut, okay? Okay, our shortcut says if we are looking at imaginary conjugates, that it's going to be the first thing squared plus the second thing squared. So our first thing is x, first thing squared, plus our second thing squared, and our second thing would be 2, right? So 2 squared, you should have ended up with x squared plus 4. Questions? If you are not feeling comfortable with that, you can FOIL. FOIL always works, and it would get you to the exact same answer, okay? Multiply out one more time here. Let's see, x cubed plus 4x minus 4x squared minus 16. And then put this into our specific information here. F of x equals a sub n times that. And fill in specifically for x -1 and that it's going to equal -50. All right, let's figure out what we got here. This would be -1. This would be -4 times 1, which is -4. This would be -4. This would be -16. Altogether, -25. Yes. Yes. All right. And then just plug it back in to figure out our specific polynomial. Distribute that 2 all the way through. And I got 2x cubed minus 8x squared plus 8x minus 32. Questions? All right. We have seen this before, so I just want to make sure that we are good to go on this particular type of problem. But when they give you a picture like this, it says given an incomplete picture of the graph, so we are not seeing the whole picture. Find all of the zeros of the function and then draw a complete graph. So first of all, when we are looking at this, delete the graph part of it. I would have told you to grab your graphing calculators, go type this into Y1, go look at the table to find your zeros. But if they give us a picture of the graph, can't we even speed that up and not even have to go type it into my calculator? What information are you looking for in that picture that's going to help us? Yeah, the zeros on the x-axis, where it's hitting our x-axis, those are zeros of our function. Remember how all those things are related to each other, right? So I don't have to go type this into my calculator. I can already tell, oh, that doesn't move. I can already tell you what the zeros are. We have a 0 right here at x equals 1, and we have a 0 right here at x equals 3. So it's already giving me that information. I don't have to go to my graphing calculator. Could I go to my graphing calculator and get that? Yeah, but then that's me typing all of that in. So using that to solve, I just come over to my synthetic division. Again, I don't know how to factor something like this. So I'm going to use the zeros I see to get this down to something I can work with. It does not matter the order that you do these in, but I would use both because I'm guessing after we use one, we're still not going to be able to factor. So let's use 1 times 2 is 2. That'd be 4. As expected, I get a remainder of 0. We're going to pause right here. I do see another 0 up there, right? So I could do this again with 3. But I need to talk to my good number sense people out there. My good number sense people out there. Look at 2, 4, negative 18, and negative 36. Is that factorable? It is. If I take out a 2 here, I'd be left with 1 and 2. If I take out a negative 18 here, I'd be left with 1 and 2, wouldn't I? It's actually factorable. You could stop and factor and find the rest of your zeros. I'm not going to stop because I see another 0, so I can just do a repeated synthetic division. Let's see, 6, 10, 30. Negative, oops, positive, how about 12 and 36, 0. So now again, I can stop. At this point, I don't have to go guessing and checking any more zeros and factor. Remember always, if you have a GCF, you can take that out to make things easier to factor. Looking for factors of 6 that add up to 5. Would be positive 2, positive 3, and there's the last of my zeros. I expected 4 of them. 1, 2, set these equal to 0 and solve. There's the third one and the fourth one. Okay, so again, kind of putting all this together, understanding what those mean. I don't have to do that much work. I see zeros right there in my picture. Use them the way we have when we were grabbing them out of our table. Okay, any questions on that? All right. We are going to go to your assignment tonight, which is a worksheet. I do want to make sure that we are clear on one part of this when we get there. Let me stop my live stream here.